Good afternoon, everyone. I appreciate you all taking the time to come and watch this. What we're going to be talking about today is context engineering for agentic network forensics. We have been talking a lot about LLMs and the rise of AI in their development practice, and one of the words that was coined is context engineering. Throughout the course of this talk, I hope you get a better understanding of what it means to actually build context in production systems, as well as be able to leverage Mermin and NetObserv to add to your tool belt for network forensics. Before we get into all that, I do want to start off by introducing myself. My name is Reginald Ross. I'm an engineering manager here at ElastiFlow. I've been at the company around 2.5 years now, and my background is in cloud application development with a emphasis on distributed systems. So yeah, I hope that you all find a lot of value in this talk. The things that I'm hoping you get out of it are, one, why the alert isn't the hard part. We have so many tools now to let you know when something is breaking. However, when you're woken up at 2 a.m., you don't really care that it's broken. You care about how did it come to be broken and what you can do to remediate that issue. Also, in that process of figuring out what to do in order to remediate, you are in essence building context around that error. So how do we start to move those practices from our skilled SREs, DevOps, and application engineers to our AI agents? And then in that, what tools do you need in order to provide them the necessary context to investigate further? And in that point, we'll talk more about how you can get value in your Kubernetes environment with Mermin, as well as how we enrich that information with NetObserv. And lastly, we'll talk about some tool and agent scoping techniques. I know different folks approach scoping tools and agents differently. Because my background is in communication studies, I tend to think about context as well as agentic techniques from a communication lens and a person-to-person lens versus purely through a CS lens. So I think it'll be interesting to talk through really how we got to the couple of tools and agents that we're going to build today. So with that, we'll just hop into it. The alert problem. So I know most of you, if not all of you, have seen this image before. Monday morning, you're coming in, you just poured your cup of coffee, you're sitting at your desk, and bam, 20 alerts come through, something's on fire, and you have to get it to work right now. Or even worse, it's 2 a.m. on a Friday morning or Saturday morning, and you're waking up out of the dead of sleep, and alerts are just pager duty is going off the hook and one of your services is down, and now you need to put out a fix in order to ensure your system stays alive. And at the time when you receive that alert, it could feel really frustrating. It could feel unnerving, like, what did I do to deserve this? However, when you actually pull that context together, you end up looking more like this, because this is fine. Not every alert that you get means the end of the world. And it's not until you realize the context around the alert that you really start to understand that this is fine. And this is what we want to start to move to our agents, so we don't have to be woken up at the dead of night. But as we start to think about what does it mean for this is fine, we know that we don't need all the information in the world. We just need a subset. And when I start thinking about how to properly convey context to different people, my communication studies background tends to pick up, and we end up talking about the nature of context. The person that comes to mind when I start to think about how to properly convey what's happening is this guy named Grice. He had 4 maxims to talk about what it means to be a good communicator. And he posits that there are 4 things. The first being quantity. I'm sure we've all been in meetings where you wish the speaker would just pause or give us a break to really digest all the information. And even if they do pause, they probably still keep going and overload you with information that you just can't absorb. So when we think about context, the first piece we need to think about is how much information are we giving? And does this information matter for the nature of the problem we're trying to solve? The next piece is quality. If you put fake news in, you're going to get fake news out. We always want to fact check our sources and making sure we're giving the most credible information when we're speaking. From a communication lens, it means communicating honestly and truthfully in every communication when we think about, or in every situation, as well as the communication we have with other developers or stakeholders on our team. But we still want to make sure it's always the most accurate and most up to date. The next piece is a little bit more nuanced, but it's how does this relation relate to the point? I think we tell stories different ways. We're used to seeing movies where we start in the middle, go to the end, come back to the beginning. And for a story, that makes a lot of sense. It takes us on a journey. Our users are at 2 a.m. We don't always want to go on a journey. We want to be as straight as possible. So we know how and why this information was brought into this picture, into this conversation. Because if I start talking about, I don't know, let's say we start talking about vector databases in the context of communication, that may not make a lot of sense. I need to ensure that not only am I bringing in information that's relative to the point, I also need to bring it in at the right time. Because, like I said earlier, stories tend to make sense at the end. When you understand the middle, the end, and the beginning, you can see the full picture. And knowing when to bring in information is just as important as the information you bring in. So when we think about relation, it's about how does it relate to the point, as well as at what point do we add that additional. I want to say context, but we don't want to overload the word context in this conversation. So for now, it is adding auxiliary information to your point to help the user or listener better understand the end reason. And the last piece of Grice's maxims are the manner. So going back to our movie analogy, the starting at the middle, going to the beginning, finishing at the end, it works in certain scenarios. It could be that the story doesn't really anchor itself into its listener unless you start with the middle and see where we end up. I think we see that happen often in books or poems or really literature changes the way that we can communicate a point. And we as the communicator need to understand, is this the optimal way for my listener to get my point? And sometimes you do need to start small and incrementally add information for users to, or your listener to understand it. And at some points, you can hop right in because you have a very technical audience and you don't need to spend the time priming the conversation. So the way in which you communicate it, the manner in which you communicate matters to the listener. And pulling this back to context engineering, I think about it as a communication problem. Not only the way that we talk to agents, but the way that we want agents to respond to us. There is a way that we don't want a very verbose output. We may only want a short summary at the beginning as well as justifications at the end. And as we move through our demo today, I'll show you how we sculpt our system prompt such that our agents know how and what we care about, what to pull in, and when to pull it in, such that it helps us on our forensics journey. So what we'll get to next, and I almost forgot. So some of these things aren't new. When we think about quantity quality, I'm sure you all heard of techniques called RAG, retrieval augmented generation, and that is something that came up because we know that there's additional information that could be helpful to a prompt that can push the agent to give you a more accurate answer. As well as quality, when we think about prompt management, we think about the words that we're saying and how to reduce the amount of tokens that we're putting into a prompt so that we don't incur hallucinations, as well as structuring. A good way to say that would be prompt management deals with structuring your prompts in such a way to optimize the token. I would think about prompt management as focusing on how and what you're writing, while RAG is focusing on pulling in more to give additional context. And the reason context engineering is so important is because it adds an additional layer of communication on top of that, focusing primarily on the manner and relation of what we're saying and really how the agent is going to respond to us. So in our demo today, we're going to be going through the Elastic Agent Builder. We're going to be talking about a couple of tools that we built using Mermin and NetObserv. And we're going to show you how all this ties together and why each tool is necessary at a different point in the pipeline and how it gives additional context that our agents needs to help us solve our problem. So our stack today, we're going to be working in a Kubernetes environment. We're going to have Mermin deployed as a stateful set in our cluster. We're also going to have NetObserv deployed, and then Elasticsearch, the cloud environment deployed, where all of our OTel flows will be flowing through. If you don't know, Mermin is a Kubernetes native networking agent. It sits at the kernel level of your application and listens to all the traffic coming in and out of your network. Historically, Kubernetes networking is a black box because you can either have an overlay or underlay network. Most of the traffic that happens in Kubernetes is encapsulated and you can't see what's going on. What we end up doing with Mermin, sitting at the kernel, we're able to listen to all the packets coming in. We decode them and send them over to the Rust side or to the application level side outside of the kernel. We process those packets and then export them as OTel flow records. It's important to call out that everything here is OTel native. So it goes from Mermin and OTel into NetObserv, which handles all the enrichment for the packets that you're seeing in your Kubernetes environment, and then pushes them all to Elasticsearch. The reason also that we need a Mermin in this is because traditional NetFlow won't have any of the ephemeral information that happens in Kubernetes. So yes, we could understand that we saw communication between a source and a destination. However, we know that the things that we care about in Kubernetes are the pod name, the cluster name, and the namespace name. But those things can often change because we know that it's an ephemeral environment. So with Mermin being deployed in your Kubernetes environment, listening to the K8s informer, we're also able to attribute any of the networking information to a given pod. So given your pods are talking and changing, you'll always know who was talking to whom and when. With NetObserv, we also ship around 120 or so, or probably more at this point, machine learning jobs. So you can look at anomalies in your network behavior. So as a part of our demo today, we have those anomalies running. We have those ML pipelines running in the background. And what we care about are port scan anomalies and brute force access. The two things that are interesting about port scans is that one, it could be a malicious actor trying to see if you have any ports open on your system that they could take advantage of. Or it could be an application trying to connect to a port that it thinks is available, but is constantly failing and retrying. So it could be an application or a network issue. And then for the brute force CLI, if someone is trying to SSH into your system, they want to attack your systems. They'll try to break in by any means possible using a CLI. From there, we leverage the agent builder. Because if you go back to our first point, the alert is in the hard part. With Mermin by itself, plus NetObserv and Elastic's machine learning capabilities, you could be alerted to any of these anomalies at whatever point in the night. However, you're still woken up and have to figure out what to do next. You also don't quite know where to look yet because, well, you could be delirious because it's 2 a.m. or you are new to the company and just don't have enough wherewithal to know where to look yet. And that's where our agent design comes into play. So what we're thinking and how we structure this agent is we wanted to answer a few questions first before it gives us this forensic summary. So why are we here? Tell me what kicked off this alert. And then where did this happen? So did this happen on-prem? Because it's possible that you have a hybrid deployment where NetObserv is listening over UDP for any packets from your on-prem environment. And then you have Mermin deployed in your Kubernetes cluster listening for pod deployments. And, you still need to know what happened and how did we get here? So where is this occurring? And then has this happened before? Because context not only can come from the information you're pulling from your different sources, but it also comes from historical learnings. And in this, we want to know, are there run books that have solved this issue before? Is there, or do we need to change any ACL settings, or do we need to update our cluster permissions for X, Y, or Z reasons? But after you've answered those questions, think about it and then return to me a summary. I'll show you what the actual summary and the agent builder looks like. But then once we have that, we actually get into our tool design, because to answer those questions, we need to provide a way for our agent to get those answers, right? And to do that, we provide two tools. So any anomalies that we write from our machine learning jobs automatically get written to an ML anomalies index. For a good tool, you need to make sure that you have the appropriate parameters added to them such that the agent knows what to inject and pull back the correct data. And then one of the key pieces of your tools is we want to limit the amount of data that is pulled back. Because if you think about Grice's maxims, quantity is the first thing that we started with. And that is where the art and science start to kind of blend, because depending on your model and its context window, it could be that you can pull back the first 1,000 records or maybe the first 100, but that is what you'll have to tune to see what the best results will be. But for our conversation, because the ML job operates over a window of time, I know that I don't need to pull back 100 anomalies to know what's wrong, because the anomaly was triggered because a handful of events met a criteria over that point in time. So I just pulled back the top 5. And lastly, I want to understand what is some of the network context that is going on at the time of this event. So in this, we pull some of the Mermin data, and we want to know what pods were affected by this issue. So let's get to the jobs. So coming over here, and then we pull up our Kibana environment. So the first thing we're going to take a look at are the machine learning jobs. We have 4 currently running, and these are looking at a DDoS flood, and they're also looking at the port scan. So what I have set up currently in my Kubernetes environment is the OTel demo application. If you're unfamiliar with OTel, it's really good to get you into the ecosystem, because every application that's inside of there is already instrumented. It provides you realistic mock data so you can understand what OTel instrumentation really looks like. Inside of here, after the machine learning jobs, we also ship some of the dashboards. So if you're familiar with NetObserv, you've probably seen some of these dashboards before, but the one that I really wanted to call out was the service to pod interactions, as well as some of the pod to pod interactions. Because as you're starting to triage some of the errors you're seeing, you really want to know who is talking to whom. So from these dashboards, as someone who is a SME in the networking space, you probably already know that you need to look here in order to solve some of the errors. So we can see that the checkout service has been really in use today, as well as the NetObserv application is also taking up a lot of traffic, primarily because we're sending all of our service information to NetObserv. So it makes sense that it's taking up quite a bit of this pie. So let's see what we have going on. If you go inside of Elastic, you can go inside the agent builder. And what the agent builder allows you to do is create your system prompt. A system prompt is what controls how your LLM behaves for any incoming message that it receives. It allows you to structure the format of the output, as well as give it a really additional context that may be helpful before starting any of its work. And inside of my agent, I ensured that it was a network forensics analyst. And I want to make sure I lead with the core principle, because if I am up at 2 a.m., I don't really care about the fluff at the beginning. I want you to tell me what is why are we here, and lead with that. And I ensure that the communication standards are also set up to resemble Grice's maxims, so it understands how to communicate succinctly enough such that I can take the next step as an SRE or an application engineer in my investigation process. Something to call out that's really important, not only is the tool design, but what tools are enabled for your given agents. So when you go over to the tools, currently you can have any of the standard Elasticsearch tools set up. However, if you give your agent access to them, they will use them. And because it's non-deterministic, you can't always be sure which tools that it will lean on. So what we try to do, one, is ensure that our tools have really good descriptions and naming for them, so that your agents know exactly what to use, as well as think about, are these tools that my agent really needs? If I know that this is a network forensics agent, I don't want to give my agent the full power to search everything, because it's going to overflow its context more than likely, and probably search for things that are irrelevant to our given use case. So what you can see here is that, one, we want to make sure that the agent's able to list and get any indexes that are available to us. That's going to be important, because it's going to want to pull those anomalies and also pull probably additional context from different indexes that we have set up. And then it's going to pull our 2 different tools. And if we go into our tools to see how those are built, you can see that these are ES queries, and we have our two parameters that really show what we're filtering down to. And then the same goes for the network context. And here we focus more on pod level information because our deployment is purely Kubernetes. So I have no on-prem. So I know that any flow that I'm receiving should have a pod name and all of the values that I have listed in my ESQL query. Now, going back to our agent, what we'll do is see if anything is wrong. So what I did prior to this conversation was run some port scans on our running cluster, and we'll see if our agent is able to pick up any of those changes. So what we can just start off with is just asking. So let's just start off the simple conversation. In an ideal world, we would have received alert, but because I just ran the anomalies, we probably won't receive an alert for a little bit. So we're going to just ask and start off that triage process. As you can see, it's starting to get all the network context for that given IP, and then it starts to diagnose and tell us what's going on. So what we can see here is that there was a port scan earlier today, and it's a 98% that is anomalous, which we don't like that. And you can see that the pod that was actually causing that issue was the anomaly generator pod. And in order for us to fix it, we can just delete that pod, which in our case makes sense because this is the pod that was causing our issues. However, it's really good to know that we see that the source of this error was the anomaly generator. And in order to fix it, we have the correct kube command to delete it and remove it. We also get some good information on how to update our network policy if we want to ensure that stuff like that doesn't happen again. And as well as if you don't believe the agent at all, right? We're all skeptical people. We want the agent to at least be able to give us more context. And because we know this insight is really just an abstraction over a dashboard, we tell our agents to say, hey, prove it to me. And what we're able to do is go to one of our dashboards and say, hey, is this a threat? And we can see that this IP address accessed 3,400 different ports and the client name of that address. So we do realize that this is what they were trying to get access to, as well as we probably don't want this IP address hanging around in our system. What we can say now as a SRE or application developer, I can just go and say, all right, I know that I need to kill that pod. So I personally would go back and run delete the pod, which would kill the anomaly pod that caused these issues, and then we'll be right as rain. But this is the kind of workflow that we want to start to move to, because as an engineer, I want to spend my time on what's valuable. And I also want to spend my time, I want to be able to go into a situation knowing as much as possible so I can spend less time kind of flailing around. And with structuring your prompts in this way, you're at least able to dig deeper into why the agent gave you that reasoning, as well as to see the truth behind their reasoning. And it looks like we have an identical anomaly. Also in that, you can see that there was an identical anomaly that was found at 415. So we also know that history informed this information as well. And I think that's really cool. And being able to connect those pieces really is what context engineering is about. And we want to give our agent as much information as possible without overflowing it so it doesn't hallucinate. And yeah, so going back to our pres, what I want you all to think about after listening to this is really solve the context gap. Think about how, if without an agent, you will solve a problem, and think about ways that agents aren't as limited as humans, right? So even if we understand that humans can only take in, 5 bits of information, an agent can probably take in 64. So let's think about not only how we limit information so it doesn't hallucinate, but also think about how it can operate at a higher level than we could even dream. I think if you want to understand what's happening in your pods from a network layer, you're going to need tools that can see that and that visibility to treat Kubernetes. So Kubernetes isn't treated like a black box. And that's where Mermin and NetObserv really come into play to allow you that full introspection into your network and your Kubernetes environment. Your agent design will always matter. If it doesn't, they will send you and they will over communicate to you in a way that leaves you still looking for answers at the end of your session. And then lastly, it doesn't always have to be a fancy tool. I know there are a lot of MCP servers available that you can integrate with, but a tool doesn't always have to be that verbose. It can be as simple as a query that allows you to narrow down what your agent actually pulls in. And the agent builder plus ESQL allows you to do that very seamlessly. And if you didn't see, they also have the MCP integration. So if you want to pull in additional context from like runbooks, or let's say you have a docs stored in GitHub, you would be able to pull that information in as well. So you can really know what to do next, and you can get even better results for remediation, even better than we got today. If you want to try Mermin and NetObserv, at the end of this, there'll be a QR code, but you can get a free trial of a basic or a premium license, depending on the size of the environment. But for the premium license, you will get 64,000 records per second. So if you have a lot of pods or containers running in your production or staging environment, I think that would probably be the best way to go. However, if you want to tinker and just work with your home lab, the basic license will also be really good to use as well. But it was a pleasure talking to you all. You can feel free to email me at reggie@ElastiFlow. If you want to hear me talk more about communication, you can follow us on anywhere streaming or podcasts are streamed, YouTube, Spotify. I think we're on Apple Music, but I have a episode around communication and agentic development that feel free to listen to and just learn more. But if you want to tap in with Mermin, it's an open source project, so feel free to give us a star on GitHub and open up your first PR. I love working with new people, so I would be happy to introduce anyone to the world of open telemetry and Rust.